In the previous lesson, we learned about or statements. Today, we're going to learn about and statements. So, again, there's that definition of a compound inequality. A compound inequality is something that a pair of inequalities that's joined by and or. The other day, we talked about just and or statements. Today, we're only talking about and statements. So the way we do an and statement is we're going to solve each part separately, just like we do with the or statements. But we're going to write our answer as a triple, and I'll explain what that means. Here's what a triple looks like. So we'll end up with two solutions like this, and then what we're going to do is we're going to take those and put them in a triple. This is what a triple is. You're going to put your smallest number on the left, so -1 is the smallest number, and you're going to put your largest number on the right. So I'll go ahead and just start talking about that above here, even though I already have the answer right here. You're going to put your smallest number on the left, largest number on the right. You're going to put your x between them, and then you're going to describe them. Well, this says, look how it's pointing at the -1. So it says x is greater than -1. I'm going to make it point at the -1. This still says x is greater than -1. If you look at the second one, it says x is less than 3. So I'm going to make it still say that x is less than 3. What this really means is that your solution is between -1 and 3. So we'll get into that a little bit more and look at some more graphs as we work with examples. To solve a triple, we're going to isolate the variable in the middle. We'll actually have inequalities in that triple form, and you'll see two inequalities within the same problem. When we do that, we're going to make sure we do the same thing to all three parts. Normally we do it to both sides of the equation or inequality, where we're actually going to have 3 parts. Again, we'll explain that as we see those occur in our example. When we graph them, we're going to graph both parts separately. We're going to do that lightly, and I'll just end up doing it in 2 different colors. And our final graph will only be where the both graphs overlap. Then what that will end up being is typically a shade between your triple values. So let's go ahead and look at what this graph would look like. And I'm going to do this 3 times, just like it says. So the first one is, let's change this. This is supposed to be an and statement. So we're going to have, it says less than 4. All real numbers that are less than 4 and greater than -3. And I have some major typos here. So this is supposed to be van and this is supposed to be van. I apologize for those. I do want to make this an and statement. So we're going to put a 4 on a number line and -3 on the number line. And we're going to start to describe this. Well, the first number line, okay, it says that we're going to look for things that are less than 4. So it would be an open dot on 4, and we would shade to the left. My second graph, okay, my second graph is going to have -3 and 4. I'll go ahead and put both those values on there again. The second graph is greater than -3. So I'll use an open dot on -3 and shade to the right. Now remember, my final solution, I'll go back to this, is where they are both shaded, so where they would overlap. If you look, that would be this region right here, where they overlap. So my final answer for this problem would be, we're looking at numbers that are less than 4, but greater than and greater than -3. So it'd be in between the -3 and 4.